Try to solve it yourself. Let's try to solve the A one first. As you can see, the first one is the definition of f'1. Of course, the fx needs to be continual. This is saying that f'1 is equal to 0. It will be limit as x approaches 1, fx is equal to 1. But that really doesn't make sense, so let's make a counterexample and say this is not true. When f'1 is 0, there are many possibilities. For example, fx is equal to 3, fx is equal to x minus 1 squared, x minus 1 n squared, and so on. So let's say an fx is equal to x minus 1 squared. If we put that in the first limit, it will be shown like this. Because fx is continuous for all x, we can just find f'x like this and put x equals 1 in it and find f'1, which is of course 0. But when we solve the limit as x approaches 1, this will be 0. So this A is a false. Now let's try to solve the next one, B. When this limit is this and this limit is this. The first one is f'1. Of course, fx should be continuous at x equals 1. If we change the second limit, it will be shown like this. Minus f1 plus f1, which is adding 0. Then this equation will be shown like this. And if we divide it, it will be expressed into two parts. And if you see this, it looks really similar to the f'1 definition. Of course, there is a 2 multiplied in the denominator. If we calculate the first one, it will be 0. And this, if we change minus h into t, it will be expressed like this. And because it is the same one as the first one, this will also be calculated as 0. So it will be 0 minus 0, which is 0. So the question B is correct, true. Now for the final question. When fx is absolute value of x minus 1, this limit is equal to 0. As you can see, fx is continuous at x equals 1, but it is not differentiable in x equals 1. Because of that, when we see this is f'1, so it is not differentiable, so it doesn't exist, so this is false. We can easily think of it like this, but as you really solve it, this is not true. Now let's put in fx equals x absolute value of x minus 1 into the equation. Then this will be shown like this. If you rewrite it, it will be shown like this. And we also do the same thing for the B, minus f1 plus f1, and it will be shown like this. And if we put in the fx into it, it will be shown like this. Limit h as approaches to 0, 2h, and absolute value of h minus 0 minus 2h, and absolute value of minus h minus 0. So what we have to calculate is limit as h approaches 0, absolute value of h over 2h minus absolute value of minus h over 2h. Now we need to find each limit as h approaches 0 from the left and from the right. Let's put the from the right as the first one and the left as the second one. If you solve the first one, it will be shown like this. Because h is approaching from the right, absolute value of h will be put out as h. But when we solve the absolute value of minus h, because these h is approaching from 0 from the right, it will be the minus. So it will be minus bracket minus h. So this equation will be changed into h minus h over 2h, which is 0 over 2h. And because 0 came out in the limit, it will be 0. Now let's solve the limit as h approaches to 0 in the left side. Then the absolute value of h will be minus h, and the absolute value of minus h will be just coming out and be bracket minus h. So this limit will become like this: minus h over 2h minus bracket minus h over 2h, which is minus h plus h over 2h, which is 0 over 2h. And because 0 came out in the limit, the answer will be 0. Because the limit exists on both left and right side, this limit exists, and the number will be 0. So this is true. So the true false for all the A, B, C will be false, true, and true.